All right, welcome to the second part of this unit. Um, the second part ideally would have been erosion because we just finished weathering, but I felt that there is something more important that we should discuss before we get to erosion. So in this part two, we're going to be discussing about sediments. All right. So as you know already, sediments are pieces of rocks, all right, and produced by weathering, of course. And sediments can be classified using various yardstick or criteria. The first criteria I want to look at is sizes. So sediments can be classified by sizes. For example, the biggest of sediments are regarded as boulders, usually about 25 centimeter or more, which is an equivalent of 256 mm. A little smaller than boulders would be cobbles, between 64 to 265 mm. And then a little smaller than cobbles would be pebbles. Then from pebbles you would have sand. From sand you have silt, and silt you have clay. So needless to say, based on the size of the sediment, you have a different name. Your earth science reference table, page number 6, gives more clarity to this topic. So on the right hand side of this chart, this graph, at the bottom you'll see clay there, and then it gives you a range, the diameter range. All right, so over here you see particle diameter. So by particle they mean sediment, the diameter of the sediment. So for clay, it's so very small that it is 0.0004 centimeter and below. So it has to be something smaller than that. Then a little bigger than clay is silt. Silt would range from 0.0004 to 0.006. Take note of the numbers of zeros that you have after the decimal. Really important. And then a little bigger than silt is sand, ranging from 0.006 to 0.2. Bigger than sand is pebbles. Pebbles will range from 0.2 all the way to 6.4 centimeter in diameter. Then bigger than pebbles will be your cobbles, more than 6 centimeters all the way to 25 centimeters. And then anything bigger than 25 centimeter in diameter is considered a boulder. So this should give you a glance of what particle size is the smallest and which is the biggest, and what their specific diameter ranges would be like. So I want you to pay attention to the dotted line that gives you the boundary for that particular sediment size. All right, so that dotted line and then the value attached to that dotted line does make a whole lot of difference. Now, if you recall, sediments is what comes together. It is what is accumulated, buried, deposited, compacted, and cemented to form sedimentary rock. So that is how sedimentary rock got its name, from the word sediment. So simply put, when these sediments of different sizes, when they are collected and compacted over millions of years, they form different kinds of sedimentary rocks. For example, when clay is collected and accumulated over a long period of time, clay has the particle size less than 0.0004 centimeter. When clay is deposited and compacted and cemented and buried, you produce shale. Now, when silt, 0.004 to 0.006 centimeter, is compacted, buried, cemented, and compacted, you have siltstone. So from the word silt, you have siltstone. Similarly, sand, you have sandstone. Then anything bigger than sand that is a mixture of everything else, cobbles, boulders embedded in sand, silt, and clay, all of that would make up breccia and conglomerate. So it is important you note the difference, the specific particle or sediment size that make up each of the sedimentary rock. It's another useful way to use your ESRT page 7 sedimentary rock identification. All right, cool. Next, I want to talk about the course of a river. We all know that rivers flow from where there is a differential in height, which means water only flows from a higher ground, a higher level, a higher height, all the way to a lower height. So that's why we have waterfalls. All rivers take their sources from the peak of a mountain or from the high elevation, waterfalls and rapids and all of that. And then when the river is taking its source from the peak of the mountain, from a very high height, it has a lot of energy. All right, it has a lot of energy. It flows quickly under gravity. It flows with enormous force and enormous energy. And with that enormous force and energy, it can carry different heavy loads. It can carry all sediments, including boulders. So it can move, the water can move boulders because it has that energy when it's at the peak around here. Now, as a river gets into the middle part of its life, the speed and the energy reduces, primarily because the slope is becoming more gentle compared to when the slope was very steep, when you have the waterfall and the high energy. So as a result, in the middle course of a river, there is decrease in speed, there is decrease in energy, and as a result, the river cannot carry the heavy loads that it used to carry. So the river would drop the heavy loads and only carry the moderate sediments, the moderate loads, mainly the cobbles and the sand. As the river gets to the old stage or the last stage, before it empties itself into the ocean, the river has run out of energy. The slope is more gentle, so it does not have much energy anymore. So you begin to see the river meandering. The river begins to take a snake movement because it does not have any energy anymore. So at that point, the river would drop the heavier loads. This time around, the pebbles and the cobbles would weigh them out, drop the sand, and it will only move forward with the smallest of sediments, which will mainly be silt and clay. So it is the silt and clay that the river would deposit all the way at the tip where it would meet the ocean, or right at the bottom of the ocean. So the point here is the energy of a river decreases as it moves from the source all the way to where it's going to empty itself into the ocean. The energy decreases, and as a result, the load that it carries, it will start dropping them one after the other, beginning with the heavier ones. All right, so with that said, you will notice that from the top of the mountain, as a river flows downward and flows towards the ocean, so we're going to call this the head of the river, and we're going to call this the mouth of the river, where the river would join the ocean. So as the river moves downward, the energy begins to decrease. As the energy decreases, it's going to drop the bigger, heavier loads, the boulders and the cobbles. It will drop them first. You typically see it something like this. For those of you who have been to vacation in mountainous regions, you'll see these heavy boulders and cobbles that the river has deposited right around there. As the river continues with its journey, crossing across different states and different countries, the energy reduces, and of course it begins to drop the next heavier loads, which will be the pebbles. So it drops them here, and then it moves further with only the sand and the silt and the clay. As it reduces in energy, it drops the sand. As it reduces the energy, it drops the silt, and as the energy keeps reducing, finally only the clay is deposited farther away. So you see that a river begins to deposit the bigger sediment first, and only the smallest of the sediments is taken all the way to the end. That's the reason why most rivers that are about to join the ocean, they are very muddy, very reddish, very has a lot of clay and a lot of silt in them, if you will. So take note. So this process is called sorting. So the river is sorting the sediment by separating the biggest one from the middle ones, and then the smallest one from the middle one. So it sorts them according to size as its energy decreases. You get it? Cool. All right. Now, another way that you can also classify sediments is by the way they are sorted. Now, when you have sediments that are deposited somewhere and they all have the same size, we call that well sorted, because the river did a perfect job in separating them according to their sizes, so that only those who have similar size are found in a particular area. So you call that well sorted. Then those that have a mixture of different sizes and different things all mumbled up, you call that poorly sorted or unsorted. All right, unsorted, which is this word right here, which means it is not sorted. All the sizes are just mixed up. And then you have sorted on the other hand right here as well. Now take note, this is not just river. Wind can do this, ice and different things can also do this, and we're going to learn a little bit more on that as we move on. Finally, you will see that the more the river is the more the length of the river, then the more sorted that the sediments are going to be as you move towards the end of the river. Similarly, the sediments can be classified based on their shape. So you have angular sediment and then you have rounded sediment. By angular sediment, we mean it is jagged up, it has a lot of angles, it has a lot of rough edges. Then by rounded, we mean the sediments is rounded because the sediments has traveled a long distance from the top of the mountain, thousands of miles and thousands of kilometers, all the way to the mouth of the river. So because of that long journey, the sediments has worn, the sediment has all the rough edges has been peeled off, all the rough edges has been smoothened out. So at the end of the day, the sediment is well rounded and smoother because it has traveled a longer distance. So the longer the distance the sediment has traveled, the more rounded or the smoother it's going to be. So even if the sediment is not round, you can see, compare this sediment to this other sediment here. You can see that this one right here is more smooth. All the rough, jagged edges have been taken off by erosion as it's been transported over a long distance. All right, so those are the several ways that you can categorize sediments. First, by size, where you have clay, silt, sand, pebbles, cobbles, and boulders. Then you can also classify them according to the way they are arranged, which is sorted and unsorted. That simply means the bigger size in one side, the middle size in another area, and then the smaller size at the very end. And then you can also classify them based on the shape. So you have the angular, which means they have rough edges, they have angles, while you have the very rounded or smooth sediments because they've traveled a long distance and they have been worn off. The rough edges has been worn off. So those are the several ways that you can classify sediments, and that will bring us to the end of part 2. And as usual, we're going to review some regions question, and then that'll be the end of part 2. All right, let's do this together, shall we? All right, question number 1 here says, which particle of quartz shows evidence of being transported the farthest distance by the stream? So we have this lovely stream right there, and it's asking us which of these particles, A, B, C, D, shows that the sediment has traveled the farthest distance. We just concluded that the farther the distance, the more rounded that sediment would be. So between A, B, C, and D, which do you think is the most rounded? Because the more rounded it is, the farther it has traveled. If your guess is as good as mine, our option would be D. All right, question number 2. What change will a pebble undergo when it is transported a great distance by stream? So if you've been transported a great distance, I expect it to be smoother. I expect it to be more rounded. Option A says it would be jagged and its mass would decrease. No, it would not be jagged at all. Rather, it will be smooth. Option B says something about being jagged as well. So A and B is out. C, it will be rounded and its mass will increase. No, its mass will decrease because it's gonna wear out. It's gonna wear out. So if it's wearing out, it should be getting a little smaller in size. It should be decreasing in size. So even though the first part is right, the second part seems to be wrong. So option C is out of our way. Option D, it will become rounded and its volume would decrease. There goes our answer. Yeah, definitely the particles or the sediment will be more rounded and decrease in size or volume. Question number 3. Which sedimentary rock is formed by the compaction and cementation of salted sediment 0.05 centimeter in diameter? Tricky one. All right. The key important in there is this 0.05 centimeter. What kind of sediment is that? What sediment size is 0.05 centimeter? Let's find that using our ESRT page 6. So 0.05 would be something between 0.01 and 0.1. So this would be 0.5 right here, 0.05 right there. Then this would be 6, 7, 8, 9, 10 before we get to 0.1. So it's going to be something within this range between 0.01 and 0.1. So 0.05 would be almost at the middle right here, and that means that particle size would be sand. And if it's sand, it should produce a sandstone. So sand 0.05 would be in between here, and the kind of sedimentary rock that we produce out of that would be sandstone. All right, let's see. Yeah, here's our answer. C, sandstone right there. That leads us to question number 4. Question number 4 says the profile below shows the average diameter of sediment that was salted and deposited in specific areas A, B, C, and D by a stream entering an ocean. So I see the ocean right there, and I see the stream coming in, and these different sediments are being deposited in those areas. And the question is, as compaction and cementation, we know it is compaction, cementation, deposition, and barrier that produces sedimentary rock, right? So as compaction and cementation of these sediments eventually occur, which area will become siltstone? Which area will become siltstone? Tricky one as well. What do we know about siltstone? A siltstone is formed from the accumulation and compaction and cementation of silt. So what is the particle diameter of silt? That should be the next thing coming to my mind right now. So that would help me use these figures up here. All right, so let's go back to our ESRT page 6. Silt would be something between 0.0004 to 0.006. All right, so I'll look for something that falls within that range. 0.000001 too low, 0.004 nice, and 0.006. Let's double check that one more time. 0.0004 to 0.006. Yeah, 006 right here, 0.004 right here. So it's gonna be this area C here that was going to form siltstone, because this is the diameter, the particle diameter of silt. So our answer here would be C. See that? You're smart. You're smart. You're smart. All right. Question number 5. La 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 la, and all this lovely diagram and questions and all of that there. I mean, if you have the time, sure, it's a good read. I want to go straight to the main question. And the question says, in activity 1, the 3 sizes of aluminum particles are placed in a stream with a velocity that will carry them to a lake. Carry them all to a lake. Which cross-section shows how the 3 sizes of particles are sorted when the stream slows as it empties itself into the lake? Once again, as a stream goes down the slope, it decreases in energy. So as it decreases in energy, the heavier loads will be deposited first. The heavier loads will be deposited first. A would have been correct, but I think A has it the opposite way. The stream will not have enough energy to bring the heavier loads all the way to the bottom. Rather, is the heavier loads will be deposited first. So option A is out of the way. Option B doesn't look sorted at all. I have big, middle, small, big, middle, small. This is not sorted at all. Rivers typically would sort their sediments as they progress in their journey. So B is out of the way as well. Option C does look like it. So the bigger sediments first, and then the middle ones, and then the smallest one. Yeah, that is how sorting is done. That is how a river does it. So C probably our answer. Let's look at D. D is the middle size and then the smallest size. No, that's not logical. Correct answer is C. And last question here, question number 6. The diagram below shows 3 beds of sediments deposited at different times in a quiet body of water. The sediment deposited in each bed is best described as, so I can see that this is bed 3, this is bed 2, this is bed 1, and I see that in all the beds, the bigger sediments are at the bottom because they are heavier, so they are dropped first. So the heavier ones will always be at the bottom, followed by the middle size, followed by the next size, and the smallest of sizes will be on top. And I can see that bed 2 followed the same pattern, and bed 3 also followed the same pattern as well, with the smallest being on top and the biggest and heaviest being at the bottom. Alright, so the sediment deposited in each bed is best described as A. Sorted mainly according to particle size. Yeah, they look sorted according to particle size. Our answer is probably A. Let's look at B, C, D. B. Sorted mainly according to the shape of the particle. This is not done. This particular one is not done by shape. Rather, it is the biggest that is at the bottom. Yeah, so B is out. A mixture of sorted and unsorted particles. No, they are not mixed. This is well sorted. The biggest one at the bottom, the smallest at the top. C is out of the way. D, showing no evidence of sorting. No, there's sorting in this. So our option definitely is A. Alright, that's enough for part 2. Easy breezy. Alright, see you in part 3. Bye.